Good day to one and all. I'm here to talk to you today about math and numbers. It's just a simple educational discussion. And many of you probably already know this. And I'm just talking because I'm going to be doing more of just plain educational talks. But I'll start out boring because I'm boring by nature. And I'm going to try and bring it to one level further to give a little food for thought. And the first thing I want to talk about now are numbers. Now, when you first learn numbers, you count them on your finger. 1, 2, 3, 4, 5. And you learn how to count them that way. And then you learn mathematics where you can add them and subtract them. You say 5 fingers and 5 more. That makes 10. And you learn about adding. And that's like one level further. And then you learn that that's the same as 5 times 2. You learn there's multiplication. That's one step further. And then you learn that along with addition there's subtraction, and along with multiplication there's division. Now the interesting thing about division is there are remainders. Now with the remainders, all through school you do the divisions, long divisions, and you have remainders. And finally now calculators will do the long division with the remainder, and you always seem to throw away the remainder or use it to round up or down. But you never knew, it seemed like it's just a piece of like waste. Numerical waste. And you just wanted to throw it away and forget about it. But actually, remainders are in very heavy use these days in technology. Remainders are very important. Whenever you want to send a special message, they do a calculation and then the remainder is used to verify the special message. It's called a checksum. And if they do like coding of numbers, the best codes are made with the remainders of 2 divisions. So remainders are much more important than you ever thought. And then you learn that beyond multiplication, there are powers and exponents. Like you have 5, and 5 times 5 is 25. You have squares. You say 5 by 5 produces a square of 25. There you've gone into another dimension. And you say, well, what's that good for? That's good for calculating areas. And you go, well, you don't just stop with 5 to the 2nd power, you can go to the 3rd and the 4th and the 5th, or whatever many powers you want to do. And it makes the numbers get increasingly bigger at tremendous rates. So 5 times 5 times 5 is 5 cubed, makes a cube. Would hold 125. And then there's 5 to the 4th if you went into a hypercube. So that would be 125 times 5 units would be in a cube that was a hypercube, a 4-dimensional cube of 5 on a side, if you could ever visualize that. Now, the other part of this is like I'm turning numbers into distances and dimensions. There's another way that they can make distances and dimensions rather than just say going this way and that way to make an area. there's what they call polar coordinates. It's around, goes in a circle. And these are very interesting, because the first thing you ever see is a clock, and that's sort of polar coordinates. You think of polar coordinates, you're looking down on the world from the North or South Pole, and you can see all around the world in a circle. When you have polar coordinates, you can look at any point in an area in terms of starting from a center point, and you go with an angle, and you go at a distance from that point. So you have an angle and a distance. They call it a vector. That defines any point inside the circle. The next point is you go to another dimension, the third dimension, and the circle becomes a sphere. And you know what? There's coordinates for inside a sphere, not just up, down, and in and out. They have them in terms of the sphere, in angles. 2 angles and a distance. So the 2 angles, they would call them like right ascension and declination, or you might refer them all to them also as latitude and longitude. And that way you could find any point inside the sphere based on that latitude and longitude and a distance from the center. Now, there's a word I'm looking for, and this is my little quiz for you. I'm going to go to one further dimension, a 4-dimensional sphere. It would be called hypersphere or tesosphere, I don't know. But in the 4-dimensional sphere, you could also have a polar coordinate system. And my guess is that it has 3 angles and a displacement. So there'd be latitude, longitude, which could also be a right ascension, declination, and a 3rd angle. Now, I don't know the name of the 3rd angle. Do any of you know the name of the 3rd angle? Could you please tell me in the responses down below? And that way you could define any place in a 4-dimensional space in terms of only one distance from here to there, but with 3 angles that will define the direction to it, which I think might be a very fascinating thing in terms of navigation through outer space. If you learn how to do n-dimensional polar coordinate navigation. So, I'll leave that with you all. Think about it. Comment below. Say what you will. If you know what that 3rd angle is in a 4th dimensional polar coordinate circular hyperspherical space, please let me know. And I'll be seeing you. So long.